Have you ever thought, where are the waste seashells will be disposed to? Yep, that's right. They usually will be disposed on the landfill or back to the sea. These seashells, let me take oyster shells for example, will give bad impact to our environment, such as contaminating the soil and water, as well as producing unpleasant odor. So, how can we solve this problem? I had done a research to convert waste oyster shells into calcium oxide powder through a calcination process, a process of heating solids at high temperature to remove volatile substance and oxidize it. The main component of waste oyster shell is calcium carbonate. Therefore, calcination process is a must to convert calcium carbonate into calcium oxide. This calcium oxide powder then can be used as a catalyst, a substance that can increase the rate of reaction without itself being consumed. Other than that, saturation of glycerol in market had been a concern alongside with the biodiesel industry, since glycerol is the main byproduct in production of biodiesel. Hence, in my study entitled Synthesis and Characterization of Calcium Oxide Catalyst derived from waste oyster shell for transesterification of glycerol, calcium oxide powder from waste oyster shell had been used. The transesterification between glycerol and dimethyl carbonate will produce glycerol carbonate, a value-added product of glycerol.
The reaction mechanism with the presence of calcium oxide as catalyst is as follows, whereby the calcium oxide will first extract the hydrogen from glycerol, which then producing glyceroxide ions. The glyceroxide ion will further react with the reactant dimethyl carbonate, which then allowing intramolecular nucleophilic substitution to occur, then resulting to the formation of glycerol carbonate.
XRD analysis and FTIR analysis of the calcium oxide catalyst derived from waste oyster shell and commercial calcium oxide catalyst confirm that both catalysts have similar properties. Other than that, the NMR results can help to determine the percentage of glycerol carbonate obtained, whereby 72.5% of glycerol carbonate produced when using calcium oxide derived from waste oyster shell as a catalyst, and 97% of glycerol carbonate obtained when using commercial calcium oxide as catalyst. Hence, waste oyster shell can be converted into something more valuable, such as calcium oxide powder.